Algebra is a branch of mathematics in which relation between quantities are expressed using symbols. The symbols are called variables. Variables represent real numbers. Examples x, y, z, etc. Real numbers. Real numbers are the combination of both rational and irrational numbers. Real numbers are represented by symbol R. Real numbers are represented by symbol R. Then natural numbers. Natural numbers are represented by n. Natural numbers are the numbers with only positive integers, varies from 1 to infinity. Examples: 1, 2, 3, etc. Then whole numbers. Whole numbers are the numbers with positive integers and without fraction. Without fraction, they are only positive integers. Whole numbers are represented by symbol W. By the symbol W. W is equal to, whole numbers start from 0. 0, 1, 2, 3, 4, etc. Next one, rational numbers. Rational numbers are represented by the symbol Q. Rational numbers are the numbers expressed as the ratio of two integers. As the ratio of two integers. Q is equal to m by n. N is not equal to 0. So n is not equal to 0 here. Examples. Examples of rational numbers are 3 by 4, 1 by 2, minus 7 by 3, 12, etc. Next, irrational numbers. Irrational numbers are represented by Q dash. Irrational numbers cannot be expressed as the fraction of two integers. They are non-repeating and non-terminating numbers. Examples. Root 2, root 3, etc. Next one is number line. Number line is the horizontal line with the origin, and from the towards the right of the origin you have positive integers, towards left of the origin you have negative integers. So this is called a number line. 3, here minus 1, minus 2, minus 3, it goes on. 4, minus 4. So here this is the origin. Origin is 0, 1 unit, 2 unit, from here to here 2 units, from the origin from to here 3 units, 4 units, etc. So this is the number line. We can represent the rational numbers using number line. For example, take x is equal to 1, y is equal to 2, x is equal to 1 is here, y is equal to 2 is from 0 to 2 here. So this is 2 units, this is 1 unit, x equal to 1. This is x equal to 2 units. Right. So here we can also find out we can also mark rational numbers in between two distinct rational numbers. Say x plus y divided by 2 is equal to 1 plus 2 divided by 2, 3 by 2, this is equal to 1.5. 1.5 comes here. Hence, between any two distinct rational numbers, there is another rational number. So, in between two distinct rational number, 1 and 2, there is another rational number. Here it is x plus y by 2, which is equal to 1.5. So, here x is less than x plus y by 2. And this x plus y by 2 is less than y. So, in between two distinct rational numbers, you have another rational number. This is how the rational numbers can be represented in number line. We can also represent irrational numbers in the number line. How to represent the irrational number in the number line, we will see. We call this 0, this is 1 unit, this is 2 unit. Take the positive sign from the origin. Say from here draw a perpendicular line which is also equal to 1 unit. This is 1 unit. You call this point as A. Let us call this point as A and call this point as D. Join O and D. Irrational number in number line. Irrational number. So here O D square equal to, according to Pythagoras theorem, OA square plus AD square. OD square is equal to 1 square plus 1 square. So OD square equal to 2. OD is equal to root 2. So OD is equal to root 2. How to mark this root 2? Take the compass, take this OD and cut an arc on the horizontal number line. Cut an arc, it will cut somewhere like this. So this length is root 2. So this is how we can represent root 2, which is a irrational number in the number line. We can also represent root 3 in the number line. From here, from point D, draw a line DE is equal to 1 unit. The same 1 unit, draw a line perpendicular. This is at 90 degrees. This point, call this point as E. Join OE. Join OE. So apply Pythagoras theorem here. OE square is equal to OE square is equal to OD square plus DE square. OD square plus DE square. OE square is equal to OD square is equal to 2 plus DE square 1 square. This is 1 unit. DE is equal to 1 unit. Right? So apply Pythagoras theorem. So it becomes OE square equal to 3. OE is equal to root 3, square root of 3. Therefore, this is root 3. This is root 3. How to draw this? Take the arc here, OE, draw an arc till it meets the horizontal line. It will meet somewhere here. Right. So this point is B, this point is C, therefore this is root 3. So we have marked the irrational number root 3 in the number line. So this is the procedure how to mark the irrational number in the number line. The next one, properties of real numbers. The next subtopic is properties of real numbers. We have 12 properties of real numbers which are very important in algebra. Properties of real numbers. First property, for any A comma B belongs to R, for any A comma B belongs to R, A plus B also, addition of this number also belong to R, and A into B, multiplication, the product of these two is also, it belongs to a real number, it is a real number. A plus B, addition of these two real number is a real number, multiplication of these two real number is a real number. This is property 1. Second property, A plus B plus C is equal to A plus B plus C. We have three numbers A, B, C. Add A and B with C, that becomes equal to A plus B plus C. This is the second property. Here A, comma B, comma C belong to a real number. This is the second property. And also, this also holds good. A into B into C is equal to A into B into C. Multiply BC, then multiply with A. It becomes equal to AB. Multiply A and B, multiply with C. Right. So this is these two come under property 2, second property. for all A, B, C belong to a real number, belong to R. Then third property, third property, for all A belong to R, A plus 0, A is real number, A plus 0 equal to A. This is the third property. When you add 0 with a real number, then we'll get the same real number. Right? So this is the third property. Then fourth property, for every A belong to R, A plus minus of A is equal to 0. That is, A is a real number. Add the negative component of that same real number with the real number, it becomes 0. A plus minus of A is equal to 0. So for every A belong to R. Then fifth property, for any A comma B belong to real number, A and B are real number, it becomes A plus B equal to B plus A. This holds true. A plus B equal to B plus A. Then A into B equal to B into A. So this is the fifth property. Then sixth property, property 6. For A comma B comma C belong to real number R, A into B plus C equal to AB plus AC. AB plus A into B plus C equal to AB plus AC. This is property number 6. Then property 7. For A comma B belong to R, A is less than B if only B minus A greater than 0. B minus A. A is less than B only when B minus A is greater than 0. So this holds good. This is property 7. Then property 8. Property 8. For any A belongs to R, for any A belongs to R, A square, squaring this, A square greater than or equal to 0. This is property 8. Then property 9. For any A comma B, for any A comma B belongs to R, only one of the following holds good. Only one of the following holds. Either A is equal to B or A less than B or A greater than B. Then property 10. Property 10. If A comma B belongs to R, if A comma B belongs to R, A plus C less than B plus C for all for if A comma B belong to R and A less than B, A less than B, for A comma B belongs to R and A less than B, A plus C is less than B plus C for all C belongs to R. This is property number 10. Then property 11. If A comma B if A comma B belong to R and A less than B, A comma B belong to R, A less than B, then AX less than BX, AX less than BX, this holds good for all X greater than 0, for all X greater than 0. X greater than 0, AX less than BX, right? Here A is less than B. Then property 12. Property 12. If A comma B belong to R real number, and A less than B, then A less than B, then AY greater than BY for all Y less than 0. These are all the 12 properties in real numbers.